Okay, so good afternoon. Thank you for coming for this quickie about leveraging feature toggle in your microservice. I'm Cedrick Lunven. I'm a developer advocate at DataStax during day. I will talk a little bit about database at 3 p.m. But here I will talk about what I do during nights. And 5 years ago, I created a framework, FF4J, to implement the feature toggle pattern. So feature toggling is actually in your code, put some condition test boolean to check if a feature is enabled or not, and choose the correct behavior. Okay, do you really need a framework to do that? Not that much, right? So when you look at Google and try to figure it out what you can do with feature toggle, the most common use case you can see is what we call truck-based development. And it means basically if you have to develop your own features, traditional way of doing it is to fork, to create a branch for you, create your features on the branch, and when you're ready, you will merge your work to the trunk. But everybody work with you on the same code base, and when you need to merge your work, maybe somebody has already merged his own features, and it becomes merge hell. It's pretty hard to merge and figure it out what happens. So to cope with that, people try to work, everybody will work on the trunk-based development. But hey, now, if you need to release on a daily basis and in the same times multiple people work on the same code base, then you will have to push some not finished features into productions. And to enable that, people try to use features toggle, put a flag, put that flag as off, ship to into production, and then the code is not executed. But I don't like this use case, and you know what? Because it's actually dedicated it's a trick, and it's not the way you would like to ship, it's a technical dev. So what about this one? We are in microservice architectures, and your microservice or middleware is deployed in a cluster with at least 3 nodes. And you start to ship your code with the version n+1. And maybe you know that most of the time you will use the rolling upgrade, blue-green deployment. You will shut down one node, upgrade the new version, put that node back to the cluster, shut down the second node. Oh, but what happened here? If you look at the cluster, node 1 is version n+1. Node 3 and above, it's still on version n. Node 2, we don't know. So we are really, really inconsistent here. So let's now imagine that you have put some feature toggle in your code, and you will ship and release your code with all the features disabled. And only when all nodes have been upgraded, then you click on the button, and everybody's on n+1. Consistent. And by the way, it never happened, but let's say you ship the wrong code or something bad happened in production, or the business changes mind, click again the button, and you're back to version n. Nothing to roll back here. So on top of this Boolean, you can also integrate in the features toggle framework the permissions. And doing that, okay, again, most of the case, you have your production, pre-production environment, MOA asks for the quali environment, then MOE for the integration one. Maybe you have to do some performance testing, and again, partners need another environment. You never see that, right? But it still happens. And maybe the product manager or the friend named Bob and Bob want his own environment. So if now you have defined permission in the feature toggle, you can start to deploy new version in productions and enable the new features only for beta testers. That means you need less environment. You can also test in production, but don't recall that. I never told you to test in production. But still, enable features for a subset of users, and once ready, enable for everyone. And you can do the same, of course, for intermediate environments. Limit the number of environments and test as much, as soon as you want. Last but not least, in the feature toggle framework, you can also define your own strategy, your own condition to know if a feature is enabled or not. You can define your own rules And that means at runtime, the microservice can decide if the feature is available or not based on its location, based on the server it's running, based on the time, the release date. It's your choice. Implement the way you want. Use case is you have a microservice deployed in multiple environments, multiple AWS region, for instance, and in some region you want to disable some features because the backend is not here. Well, using a custom strategy, the features can be disabled automatically for you. And with all that layer, the feature toggle framework can help you. So, but what about features? When you use a nice monolith application like that, the main things you need to think when you do features toggle is that the features will be available in all the layers. Not only the service layer, but also the UI. And if you provide a framework to help you, you need to provide some tools for each of the layers. So now imagine that you are working on a microservice. It's even worse. Your feature is obviously distributed around multiple pieces, multiple services. So you have to try to be consistent. And how to be consistent in the feeder toggle pattern? Well, we will use a storage where we store the feature states. And of course, if you have multiple services all running their own runtime, you cannot have the states located in each runtime. You want to have something distributed, use an external storage, not something in memory. So this is what you used to do in multiple applications, pointing to the same storage and having a dedicated backend applications pointing to the same storage and help you enable and disable that features at runtime through web UI. So 5 years ago, I created a framework like FFRG, means feature flag for Java, which helps you implement those features. And this is what I would like to demonstrate to you now. Okay, to do my demo, I will first start Consul, the service discovery tool. Who already know Consul? Maybe most of you, right? So nothing very special about it. So I start Consul. Then I create a small microservice, very basic one. I call it the demo console, and I provide the Spring Boot starter web because I would like to do a web UI. And I also use starter cloud Consul just for my service to connect to Consul. Just define the correct properties on application.properties, and you can start your demo applications. Okay, maybe node log, something very important. Then the demo application is here, and if I want to go to my admin, okay, I have my hello Voxxed Days, very simple app, microservice, basic sample using Consul. Then I would like to enable this application to use FFRJ. We provide the Spring Boot starter. So just by providing that starter, it will provide you in your microservice a web UI, first web UI, where you can see all the features and show if the features is there or not. Okay. But here, by default, the features are stored in memory, and this is not what we want, right? But where can we put the features, the state? Well, in the About page, you can see that it provides a couple of technology to store your features. Pick the one you want. And today, for features, I will reuse Consul because Consul is supported, and Consul also provides a key value store. This is a good way to store the state of your features. So what I do, going back to my applications, adding Consul for features and properties, and Cassandra for everything that regards to audit monitoring. We'll see that later. So I will define a bin for FFRJ configurations and provide everything it needs to connect to both Consul and Cassandra, like that. Okay, so far so good. Let's restart the very same application now. Okay, try to refresh my applications. Okay, so now we are on Consul and something is Cassandra. I will ask the framework to create the schema by itself. It will create the table in need and create the element in it. And now if I try to create a features like that, let's say features 1, okay, creating a features, then it will show up in Consul, and you can see that the features are there. So now I have my backend ready, available to use that features, and I define a couple of microservice. Again, very simple, service A, service B. And in those services, I will need to point out to the very same features storage, just to share the state. So I will copy here and start service B. Okay. And doing the same for service A. Changing the config here. Oh, and by the way, in each of the microservices, I didn't use the full starter because starter provides the web UI, and I don't want to have the web UI in a single one of my microservice. So I just define as the dependencies only the storage I need. So it's Consul and Cassandra. So now I can also start this one. And those services actually need one features. If you look at the controller, it expects to find something callus, and it will try to invoke callus. But we didn't define callus. So we ask the framework to create those features at runtime when needed. So it's starting now, and now if I try to invoke one of the service, this is a support service, and this is service A, and this is service B. And they tried to invoke callus. It was not there, but so it has been created for us. It's created, but it's false. And on the UI, I decide to put that on, and the features in enable, and you can see that it's there. But when we define the feature storage and storage available in all the microservices, we can also define properties, because we provide all the implementation for all kind of storage, and we can also create some properties, and those properties will be available in any of the application as well. So this is a sample properties. Oh, not like that. Okay. And okay, so now I have a phone number. I should be able to display my phone number, just the properties. It's available, I display it. Last but not least, each time you have to invoke a features, then FF4G will be here to evaluate if the features is true or not. So it's exactly the best moment to store if a features is used or not. And this is one of the features we provide. We provide some monitoring, and we store all the events in the storage you want. Here it's Cassandra. And you can see, oh, it's not nice, it's a single features. But if I go back to the features and also use another open issue, I should now have, okay, a new features and go back to the monitoring. It's better. Now we can see which one is used the most, and you can also see when they are used. And you can try to give your business which features is used and which is not. And nothing to implement in your code, it's just provided by the feature toggle framework. So That's it for the demo. I just wanted to give you in 10 seconds things we did not see. We also provide a CLI because not all the services provide web UI and GMX. The REST API because most of UI are developed in JavaScript. Provide some caching to avoid overhead by accessing again and again the database. And AOP, we would like to flipping using annotations and not only ugly if-then-else condition in your code. So then put an annotation on the interface and other annotation in multiple implementations, and FF4G will choose for you which one to pick. So if you like it, everything is available on GitHub at those URL. More information on FF4G at ff4g.github.io. If you want to try it right now by yourself in a 3-line of code, here it is. No database needed. It will start up something in memory. And if you like it and would like to thank us, GitHub star is at least one thank you. And thank you.